So my name is Joanna.
Oh, nice. And what do you do here?
So I'm currently the support astronomer for the Facility Adaptive Optics System. So this is mainly used in conjunction with an infrared camera and spectrograph as well, called RCS.
Okay.
So my duties kind of is a 50-50 split between supporting other astronomers, carry out their observations at the Observatory, and then I also spend part of my time conducting my own personal research, which is kind of in the field of star and planet formation.
Nice. So you sound like you're not from Hilo, so how did you get here?
It's a very good question. It took a while, but I got here eventually. So I'm originally from the United Kingdom. So when I was about, I'll say, when I was a teenager, I saw, I actually was watching a British documentary called Horizons, and I saw some, they have these great segues of astronomers talking about all these exotic objects like black holes and supernova and galactic nuclei. And then they segue to astronomers at the summit of Mauna Kea, just outside observatories, and they've got this glorious sunset in the background on this kind of Martian landscape. And I was thinking, God, how can you get to be there? Like, how do you do that? Like, how can that be a viable job path? So that kind of got me interested in astronomy. And then from there, like, I thought it would be more practical to kind of follow physics at university level. So I really enjoyed mathematics and sciences. I did physics at university, and I did my master's degree there, and then that kind of pursued into a PhD program as well. So the university I went to is one that was focused towards basically star and planet formation in the fields. And then I kind of got hooked into that area as well because I thought it was so exciting, like especially in today's kind of current research is hot off the press. Like we're actually directly detecting planets around new forming stars. So it kind of is such like an exciting and like fast developing field, and kind of to be at the forefront of that is kind of very very cool for me.
It is cool.
So when you say that you're discovering new planets, what does that look like? How can you tell that there's a planet there?
It's not as simple as it seems.
No, I wouldn't think it would be.
So unfortunately, the problem with detecting planets is that they're so very faint, and then they're kind of blasted by the starlight from the surrounding coasts. So to do that, you have to use what's called a chronographic imager. So you essentially mask out the starlight. And then this creates better contrast ratios so you can detect like fainter signal from planets.
So you're looking for the reflected light off of a planet by cancelling out this.
It's not the light is from the planet itself. So the planets are so young that they're still hot. They're still hot. So they're actually emitting radiation. So you're detecting radiation from the planet itself.
Okay.
But as the planet ages, it decreases in luminosity, so they're much harder to detect. So you're detecting kind of young planets that aren't really formed.
Okay, and so my little girls that are sitting back in Raymond, Alberta right now, is it worth it?
It's worth it, yeah. It's definitely worth it. Like, I've come from the UK and I'm now living in Hawaii, and yeah, you get to go, it's fantastic. It really is.
Yeah, I can see that. That would be awesome, for sure.